Okay, so let's consider this case. Let's consider the case of x plus y equals 4 and 0 equals 0 that came from this system here. How do we write the solutions for this? Well, we have x is leading and y is free. We do back substitution. What we say is we solve for the leading variables in terms of the free. So we'll say x equals 4 minus y. Okay. Now what's going to happen is this is where it gets a little tricky, because what we want to do is we want to write this as a set of vectors. We could write it as a set of ordered pairs. If this is x, but we already know that x is 4 minus y, so we could remove the leading variable and we could write it like this, right? So x is 4 minus y. So since y is free, I choose any number y. For example, I could choose y equals 1 here, and this would be 3. So there's a solution. Or I could choose y equals 2. That's the solution, right? Do you guys questions? Are you guys not? Okay. So this is one way of writing. You can see that there's if I eliminate the leading variable is like the dependent variable. So if I write everything in terms of free variables, they're free because I can choose any value I want for them, and then solve this equation here to get a solution. Well, what I want to do is write this as a set of vectors. So I do the typical thing after I've solved for the leading in terms of the free and put it in here, I can write as a vector 4 minus y and y. Okay. But now, the reason we're going to think of this as a vector because I can do stuff with vectors. So there's going to be two things I can do with vectors. I can add vectors. We're going to talk more about this in a later chapter. We only need this one pattern here, so we don't really need to worry too much about this. But what you do is you say, well, the top row gets added to, this operation goes row by row. So 1 plus 3 is 4. 2 plus 4 is 6. Okay? So that's what we can add the vectors. We can also multiply vectors by a number. So for example, 5 times 1, 2 equals 5 times the first number is 5. 5 times the second number is 10. Okay, so I want you to practice that right now. So let's say I have 2, 3 plus 5, 6. What does that equal? So you have 7 and 9, right? Okay, and then how about you can combine these operations? How about 3 times 1, 2 plus 2 times 3, 4. What does that equal to? So, someone else have wanted to tell me their arithmetic for the first number up here? Does someone get?
I have 9, and then we borrow by 14.
9 and 14. Yeah. Okay. So you guys get this. Okay. So the point of this is we're going to use these operations. So up here we have this thing 4 minus y and y. Okay. Well, now we're going to use these operations in reverse. We're going to think of this as sort of lined up like 4 minus y, 0 plus y. Okay. So I can sort of think, and I can think of this minus sign here as maybe plus a minus y. So I can undo the addition here as 4, 0 plus minus y. Okay, so if I look at this backwards, I have 4 minus y and 0 plus y, get this. So I'm just running those operations backwards, sort of undoing the addition. Is that okay with you guys? Okay, then you can see I have a common factor here in the variable y. I can factor that y out and write 40 plus y times minus 1. Where this is like minus 1 times y and 1 times y, and I just factored out the y. So that's undoing this multiplication operation. And that's the form in which I want. So I'm going to write that my solution set for this equation, this system here, of 4 plus y, x plus y equals 4, or the second equation is 0, is the set 40 plus y minus 1. Now this vertical bar here means such that, that's a little math notation thing, right? Such that y is any real number. This is the symbol for in. Like if I say, if A is the set 2, 3, then I say 2 is a member of A. This is one of these things in chapter 0 that reviews this sort of little symbol here. So this is sort of, it's a very fixed pattern here. And you can see this is the form in which we'll write the solution. We have an infinite number of variables. We'll say, okay, y can be any real number. And we can say, well, it's this vector here plus any amount of this vector here. And this gets us everything. Okay? So you can easily, it's like a nice form because you can sort of see, okay, if I choose y equals 0, 40 is a solution. If I choose y equals 1, I can add the vectors and get a solution. And it sort of separates off these two pieces. Okay. So let's see. What I want you to try to do is try this form now. X plus y plus z equals 4. See if you can write the solution set form of this equation. What's in that way with that we just did? So you want it. So first of all, which variable is leading? X, and which variables are free? Right. So you want to solve for the leading variable in terms of the free variable. Also, if you write a vector, how many levels or components is the vector going to have? Three, as Rami said, it's going to have 3. So your vectors are going to have 3 components or 3 levels, three sort of heights in them.